Okay, so of the ones that we have listed, this is our strongest oxidizing agent. And of the two reducing agents, this is the strongest because water is up here. So remember, stronger reducing agents are towards the bottom. So right to half reaction. So the strongest oxidizing agent how many waters is there? 8? No, 8. Oh. So, from the data booklet in my head, there is your reduction half reaction. Now, our strongest reducing agent was Fe2+. So I'm going to take him. I'm going to start on the right hand, or the right hand side, and I'm going to write it backwards. Fe2+ yields Fe3+ and 1 electron. So what I've done is I've taken this guy and I've written it in this direction. Okay. Now, the permanganate gains 5 electrons. How many iron 2 ions does he need to gain those 5 electrons from? He needs 5 of these guys. So we need to balance those ones off. Now, what we do is we add these together now. We have 1 MnO4 plus 8 hydrogens plus 5 iron 2 plus 5 electrons. I'm not going to write them down because I also have 5 electrons on the right-hand side. So oops, I need 5 of those. Forgot to put 5 of those down. So this is the balancing part. We have to balance using, well, the number of electrons. Step 5, predict our spontaneity. Well, let's go back to my chart. My OA is up here. My RA is down here. Is that a spontaneous reaction? Yes, it is. So to indicate that it's a spontaneous reaction, I'm just going to write spontaneous spawn. You can also indicate it in other ways, but that's the easiest way. Do we have a question? Okay, this reaction here, what's happening? It's the reducing agent, so it has to be. It's going to lose electrons. So when we, oh, for Pete's sakes. So the reducing agents, the reaction is going to be taking from, as it's written on here, from right to left. We start with iron 2 plus, we end up with iron 3 plus and an electron. So we have to write the reducing agents always from right to left. That's why we have this double arrow in here, meaning that this reaction can happen in the left to right form or the right to left form. So the next example. Determine the most likely reaction when chlorine gas is bubbled into, and hydrogen gas is bubbled into an iron 2 sulfate solution. So chlorine gas, Cl2, H2, for a hydrogen gas. We have a solution of iron 2 sulfate, and because it's a solution, water. So what do we have? Elements stay in their elemental form. Ionic compounds break apart. Strong acids break apart. So a solution of nitric acid would consist of hydrogen ions and nitrate ions, where a solution of nitrous acid, HNO2, because it's a weak acid, would stay at HNO2. Please go through your data booklet and assign these guys OAs, RAs, and SOAs. So make sure when you're looking at your table, you're not grabbing an equation that doesn't have something that's listed or has something that's not listed. Is Cl2 an OA or an RA? Derek? Is H2 an OA or an RA? H2? Okay, H2. Where the heck is H2? H2 is down here. So you are correct. It is an RA. Right, it's on the left hand or the right hand side. That's very increased. Now let's go back to the Cl2. That's where I think I've made my brain freeze. Cl2 is right there. Okay, so that's correct. That's an OA. What about Fe2 plus? Well, we just talked about that guy. He is both an OA and an RA. We talked about this guy here, although he's harder to find. He's way down at the bottom. We have water and sulfur, or the sulfate ion down here. So way down at the bottom, but he is an OA. And the final one is water by itself. Water by itself is an OA there. And water by itself is an RA. Need to go a little higher. Up here. Okay, so water is an OA RA. Oh, so because it shows up so often, you should just have that one memorized. Sean, what's my strongest reducing agent, or sorry, strongest oxidizing agent on this list? This is the strongest oxidizing agent because it's right at the top. Way at the top there. And the strongest reducing agent out of our list, well, we have our iron 2 up here. We have our H2 right here. So and water's up higher. So which one's the strongest one there, Alexis? Right? So here's our strongest reducing agents. The iron sulfate solution really doesn't matter in this case. It's nothing's going to react with it. So right now what we have, Cl2 plus 2 electrons yields 2 chloride aqueous. We have H2 gas yields 2 H plus aqueous and 2 electrons. So again, I took my reducing agent and I wrote it from right to left because I have hydrogen gas. It's going to give me the hydrogen ions. Do we need to balance any electrons? We have 2 electrons gained, 2 electrons lost. I'll come right back to this. And again, because my OA is up here and my RA is down here, it's that the OA falling above the RA on our table. Therefore, this reaction will happen spontaneously. I have a question. Does anybody know what measurable property will change throughout this reaction? Now, we're not going to create bubbles. We're going to have actually gas disappearing. Anytime you create or use hydrogen ions, what measurable property does that change? Yes? pH. So we're creating more hydrogen ions. So what's the pH going to do in this one? Go up or go down? The concentration, and by the way, it's a reason why I asked, this concentration of the hydrogen ion goes up. But the stronger the acid, what's the pH? What's a stronger what's a stronger acid? A low pH or a high pH? So since the concentration of the hydrogen ion goes up, the pH will drop. And that's why I asked that, because it gets more acidic, and then you think the pH goes up. So remember that pH drops. More acidic a substance is, the lower the pH is. So I would like you to go through and write all of the entities present in this system and assign OAs and RAs to them. One step away from over here. This column, -1, -2, -3. Those are the basic. The non-metals are going to gain an electron. So they're going to flow with a negative charge.
There's no consistency.
Okay, there is one thing that I should point out. Do you notice there are no charges on any of the non-metals here? And the reason is for that, what I've heard, is what we say the charge for oxygen at 2 negatives. That is only one of many charges that oxygen could form. So we don't actually get into, they don't want to put it down there because it's too simplified. But remember what we have. You can go ahead and write them in your data booklet. If it is one group away, so group 17 here, it's one away from the noble metals. Non-metals want to gain electrons because it's one group away. It can gain one electron. So this column here is going to be -1. Oxygen, it's two groups away. Non-metal wants to gain, it's going to be -2. The nitrogen phosphorus group is 3 away, so it will be -3. We do not have carbon and silicon. We do not expect you to use carbon and silicon in this. Because carbon, as far as I know, has never been found to form an ion, and silicon has, but we don't use it enough to really worry about it. So 3 negative, 2 negative, 1 negative. So we have solid aluminum. That means we have metal, solid. We have mercury, so mercury 2. We have a chloride ion. And we have water. Water being your OA, your RA. Chloe, what did you have chloride as an OA or an RA? Give you a minute. It's a very, very weak RA because it's near the top. Mercury 2. I actually have to hunt for this one because I use it so rarely. Mercury 2 is an OA near the top. Aluminum is an RA. So again, just go to your table, find them. We have mercury 2 up here, my strongest OA, because it's stronger than water, and we have aluminum solid down here. It's a much, much stronger reducing agent than our chloride ion way up there. Okay, so our strongest OA is our mercury 2. And our strongest RA is our aluminum. And then we have our aluminum creating aluminum 3 ions and 3 electrons. So again, I'm reading that reaction from right to left. How do I balance my electrons here, Jamie? And keep going. I need 3 of those, 3 of the mercury because it's giving up 2. So now I've got 6 electrons being gained by having 3 aluminum, or sorry, not 3 aluminum ions, 2 aluminum ions, or 2 aluminum atoms. I have 6 electrons being lost. I won't bother writing the 6 electrons being gained. Or the 6 electrons being lost. while you're writing that, what would you see as this reaction progresses? What evidence would you see as this reaction progresses? Well, I've got aluminum solid here, and I don't have aluminum solid on that side. So what I have is aluminum disappearing. So I have aluminum disappearing. My solid aluminum would be eaten away. I have liquid mercury being created. So I would see I would see a liquid, or I would see a silver metal being created. Now, what's the difference between aluminum and mercury? Well, mercury will kill you. Aluminum won't. But aluminum is a solid at room temperature, and mercury is not. So that's the process. I don't expect you to memorize anything. I only expect you to be able to use the table. This table is not easy sometimes to find. Just you have to be very patient on it. Now remember, there are 3 metal ions that occur on both sides. Iron 2, chromium 2, and tin 2. They occur on both sides of this chart. The 4th one that occurs on both sides is water. Those kind of have to be memorized, that they occur on both sides. Okay, so you have 4 questions to do. If you have any questions, please ask. Yes, you may go to your textbooks if you don't have them.